So in this video, we are going to see a graph theory 1 mark question from GATE 2030 paper, and it's based on the topic of degree of the graph. So let's see what the question is. Which of the following statements are true for undirected graphs? So we are given two statements, statement number P and statement number Q, and we have to see which one of them is true or which one of them is false for undirected graphs. Okay, so let's start reading question number P first. Number of odd degree vertices. Number of odd degree vertices is even. So when you read this question, right away you cannot immediately say whether it's true or false, because we are talking about all possible undirected graphs. So the way I'm going to approach this question is, we will start with small simple graphs with 2 vertices, graphs with 3 vertices, have random number of edges, and then we'll see whether statement number P holds true or false. So let's start with a graph with 3 vertices. Okay, and I'm going to connect it like this. Now let's see the degree of every vertex. So what is the degree of vertex? A degree of vertex is the number of edges that are incident on it. So as you can see, one edge is incident, so degree is 1. Here 2 edges are incident, so the degree is 2. And here again one edge is incident, so the degree is 1. Now for this simple graph, simple undirected graph, statement number P is true, because the number of odd degree vertices is even. We have 2 odd degree vertices. Okay, so the statement number P is true. Now let's try to complicate this graph a bit. I'm going to add randomly 2 more vertices, and I'm also going to connect it randomly with some edges. So here we go. Let me just randomly connect it like this. Okay, now let's find out the degree of vertices again. So for this it's going to be 2, for this it's going to be 3, for this vertex it's going to be 1 2 3, for this vertex it's going to be 2, and for this vertex it's going to be 1 2 3, so it's going to be 3. Now again, if you focus on the statement number P, it says number of odd degree vertices is even. So as you can clearly see here, okay, I made a mistake. Here the degree is going to be 4. This is going to be 4. Okay, so as you can see that the number of odd degree vertices is again 2, 3 and 3. So there are 2 vertices which have odd degree of vertices, and there are 2 vertices which have odd number of degrees. So now let's try to think in the reverse way. Let's try to draw a graph which will have odd number of odd vertices. Okay, so for example, now I'm going to really try hard, imagine hard, and draw a graph which will have odd number of vertices. Okay, odd number of odd vertices. So let's say this graph, it has a degree of 1. So this has a degree of 1, this has a degree of 1. So again the number of odd degree vertices is even. Now if I want one more odd degree vertex, I can use this vertex, but the moment I create an edge, this becomes even. This becomes odd degree, but this becomes even. So if you try to do this exercise for a little longer time, you will see it is impossible to come up with a graph which will have odd number of odd degree vertices, because the moment you try to bring one more vertex and try to connect it somewhere, this becomes even and this becomes odd. So the number of odd degree vertices always remain even in any undirected graph. So we're going to say statement number P is absolutely true. So let me just clear this off. Clear this off. Okay, so I'm going to say statement number P is absolutely true. Now let's go to statement number Q. The statement reads, sum of degrees of all vertices is even. If you do the summation of all degrees of vertices, it's even. Again, we don't know whether this is true, whether this exists, whether this statement is true for all undirected graphs in the world. So we're going to start really small. We're going to start with 1 or 2 vertices and then try to complicate the graph. So here we go. Oops, let me take this color. So we have again three vertex graph, and let's totally connect it. Okay, let's quickly write the degrees of the vertices. It's 2, number of edges that are incident. This is also 2. Okay, and this is also 2. So here very clearly the sum of degrees of all vertices is even. Now let's try to complicate this graph. Let me add another set of vertices, 1 here, and let me randomly connect them. So let's connect it like this. Okay, that's it. Let me connect it that way. Let's see the degrees of vertices. It is 1 here, Okay, here is going to be 1 2 3, so this is 3. Here is going to be 1 2 3, so this is going to be 3. Here is going to be 1 and 2, so this is going to be 2. 1 2 and 3, so this is going to be 3. So as you can see again, once again, the summation of degree of vertices is going to be even. If you do the summation, is going to be an even summation. So once again, you can do this exercise. You can try really hard to draw an undirected graph where the summation is going to be odd. And if you really do this exercise for some time, you will find out that it is impossible to draw a graph where the summation of degree of vertices is odd. So statement number Q is also going to be true. Now, P is true, Q is true. So option C, both P and Q is our right option. Be careful, they are asked in the question for true statements. Hence you have to mark C. If in the question they have asked for false statements, then option D would have been the answer. So don't be very desperate while marking the option. Read the question again and then mark the correct option.